Welcome, Algebra students, to our notes on section 9.4, factoring to solve quadratics. The key word there is solve. When we're talking about solving quadratics, we're talking about quadratic equations. That means those with an equal sign. Up until this point, we've just been factoring without the equal sign. As you see in this previous example there's no equal sign. Now we're getting into how do we solve a quadratic. The first thing you need to understand is the zero factor property. This essentially means if we have two factors, two numbers, two terms, two variables, whatever it is, multiplied together, and it's set equal to 0. That means one of two things. That means then that A could equal 0 or B could equal 0. Okay, so you're always going to have two potential answers with quadratics. So you're going to set A equal to 0 and B equals 0. Let me give you an example why. So let's say A equals 6, and then we're going to say B equals 0. So if A equals 6, well, 6 times 0 is going to be equal to 0, so that's a true statement. Okay, now what if A is equal to 0? So if we have A equal to 0 and B equals, it doesn't matter, we could say negative 200. So now we have 0 times negative 200. Does that equal 0? It certainly does. So it doesn't matter which of these is equal to 0, A or B. As long as they're multiplied together, all you need is one to be equal to 0, and then it works. One of the key points with quadratics equations and solving them is you always want to set the equation equal to 0. That's very important that that is first set up. Now let's go ahead and get started. Here we have two binomials multiplied together, x plus 3 times x plus 2. It's already in factored form. What we need to understand here is either one of these parentheses can be set up equal to 0, and it will make a true statement. Let me demonstrate. Well, my green one is a lot more sloppy than my blue one, but you get the point. So x plus 3 could be equal to 0, or x plus 2 could be equal to 0. So what we're going to do is we're going to solve for both of these, just like a linear equation, two-step equation, one multi-step, whatever it is. So we get x equals negative 3. After subtracting 3 from both sides, we're solving for x here for both of these equations, 2 times, 2 answers. So we get x equals negative 3 or x equals negative 2. What happens when we plug these answers in? Well, let's first start with x equals negative 3. Clearly, you can't plug in two different values at the same time, so we're going to take turns here. We're going to plug in negative 3 first. So negative 3 plus 3. So we're going to plug that in for x. This was x plus 2 equals 0. We get negative 3 plus 3 on the left is 0 times negative 3 plus 2 is negative 1. Does that equal 0? Well, 0 times anything equals 0. 0 times negative 1 is going to equal to 0. That checks out. Let's try the next one. Let's plug in negative 2. So we have negative 2 plus 3. Okay, this was our value of x. Then we have negative 2 plus 2. That was our value of x. Does that equal 0? Here we have negative 1 again. And then here we have 0. Does that equal 0? Well, negative 1 times 0 gives us 0. So that one also checks out. So that's why we have two answers here that work. We can have negative 3 or we could have negative 2. Let's move on to the next one. Same deal here. We could have this parenthesis equal 0. Or we can have this parenthesis equal to 0. Let's start with green again. 4t plus 1, we're going to set this equal to 0. So we're going to solve for t here. We have 4t equals negative 1 divided by 4 divided by 4. T equals negative 1 over 4. Yes, you can have fractions. That's going to be one of our answers. Then we have t minus 2. We're going to set this equal to 0. We add 2, we add 2. We get t equals 2. So that is our second answer. If we plug these both in one at a time, if we plugged in 2, we'd get, just as a demonstration, plus 1 times 2 minus 2. So we would have 9 times 0. Of course, that equals 0 because anything times 0 equals 0. And then the same thing for negative 1/4. We'd plug negative 1/4 into the green right there, and we get 0. 0 times anything. It doesn't matter what fraction this blue is. If we're multiplying it by 0, it equals 0. Most of your quadratics are going to be in this form, though, which means you have to factor before getting started. So we're going to factor here. If you recall from factoring, we're going to put the first term's factors in the first slot, and we're going to put the last term's factors in the second slot. This one's fairly easy because the factors of t squared are simply t and t. So we're just going to put t and t here. Not t and t. We're not going to do that. That's dangerous. T and t. Okay. Now we have negative 54. This one's a little bit trickier. Because it's negative, that means the signs need to be opposite. Either this needs to be plus and this minus, or the other way around. We'll figure that out in a second. But we should also realize that this middle term is positive. Keep in mind the middle term is a result of the sum of the outside product and the inside terms product. That's something we got to keep in mind. Let me change the color to green. I want this to be green. It makes it stand out. There. Okay, so we need to think of factors of negative 54 that have a sum of 3t when we do the outside and inside terms multiplied together. So we have negative 9, positive 6. We have positive 9, negative 6. We have 27, negative 2, negative 27, positive 2. We probably have a few more, but we can stop here because I recognize something. I recognize that if I'm looking for a sum of 3t, well, I already have it here. I have 9 plus a negative 6 gives me positive 3. And since I'm going to be doing it with the product of the outside and inside terms, I'm going to be multiplying by t. So I know that my answer is going to be positive 9, negative 6 equals 0. Most people will stop at that point. So let me just show you negative 6t, positive 9t, negative 6t, plus 9t equals 3t, which is this right here. Okay, do not stop at this point. You're not done. What we need to do still is we need to set this both equal to 0 to find our answers for t, because we want t equals two numbers. So we have t minus 6 needs to be equal to 0 there, and we have t plus 9 needs to be equal to 0. Add 6, t equals 6, minus 9, or t equals negative 9. Here are our two answers, and now we are done. On to the last one. This one's going to be the tricky one. First, you notice that it's not equal to 0, so we need to subtract 18 to both sides to get it equal to 0. So we have 4x squared minus 21x minus 18, and that's equal to 0. We're going to put two parentheses like we did before. Okay, we have our factors of the first term go here. Our factors of the last term go in the second slot here. Now this one's going to be a little bit trickier for a couple reasons. Number one, we have 4x squared. So we have two potential candidates. We have 2x and 2x, or 4x and 1x. Then we have negative 18. So we know that the signs need to be opposite, plus and minus. So we can have negative 9, positive 2, positive 9, negative 2, positive, not 4, positive 6, negative 3, negative 6, positive 3, and I think that's it. So we have a bunch of combinations here, and we could literally go through each one. We could try 2x and 2x, sorry about that x, with each one of these combinations, which would take a long time, and then we could plug in, whoops, my parentheses disappeared, there we go. Then I could plug in 4x and x and try each one of these combinations again, but that would take a long time, so let's be a little strategic here. Now, I know I need to get to negative 21, so if I'm multiplying small numbers together, I'm not going to get there. I need to get there kind of quickly, so I need to multiply some bigger numbers together. So I'm going to go ahead and try 2x and 2x. I'll go ahead and try that one first. Okay, but I'm going to use these bigger factors first because I know I need to get as close as possible to negative 21. If I multiply 2 times negative 9, I know I get to negative 18, and that's pretty close to negative 21, so I'm going to try that first. So I'm going to do negative 9 and positive 2. Why did I choose a negative 9 as opposed to a positive 9? Because I recognize this is negative, this middle term, and that these outside and inside terms need to add up to give me my middle term, I know I need to have the bigger number be negative. So that's why I put a negative 9 there, because I want to multiply 2 times negative 9. That gives me negative 18x. And then I have a positive 2 times positive 2x. That gives me a positive 4x. Guess what? I got to negative 14x. I did not do this correctly. So I know by using my greatest factor that it wasn't enough. So I'm going to try something a little bit different. Let's try a different factor here. So I'm going to not try these ones. I'm going to try a different factor. Okay. Now, if I change this to 4x and leave that as x, now I get too big. I have negative 9 times 4 is negative 36, and now I'm too big. I'm too negative. So what I'm going to do here is I'm going to change this to 4x, but I'm not going to use the negative 9 anymore. I'm going to try it with the negative 6. Again, our negative needs to be the bigger. I shouldn't put a 3 here and 6 here because I need my biggest number to be negative. So I'm going to put the 6 here and a 3 here. What happens when I do that? Well, I have a 4x times a negative 6. That gives me negative 24x. Then I have a 3 times an x here. What happens when I do negative 24x plus 3x? I get a negative 21x. So now I know that I've done this correctly. It's equal to 0. So I can go ahead, set this equal to 0, and then solve for both binomials, both parentheses. So I'm going to set 4x plus 3 equal to 0. Subtract 3. 4x equals negative 3. I'm going to divide by 4. I get x equals negative 3 over 4. There's one of my answers. This is going to be the easy one. I have x minus 6 equal to 0, add 6, I get x equals 6 as my second answer. So there you go. This one's a little bit trickier. A lot of teachers will teach you factor by grouping. I think that's a waste of time to learn personally. This is much easier, I think, with practice. And besides, if it gets to a really complicated situation where you have tons and tons of different factors of both of these, it's going to make more sense to use the quadratic formula anyway versus factor by grouping. So there you have it. That's my opinion. I'm not a professional. It may not be the best way, but it is the best way. Take care, and I'll see you next time.